6.5 Day 1 deals with some graphing and solving of inequalities. We're going to start out with just the inequality symbols. Greater than sign. Remember, we read left to right. So if something is greater than something else, this mouth is going to open to the left. Something less than, the mouth opens to the right. And greater than or equal to is going to be opening to the left with a line underneath it. That's the or equal to part. So there's less than or equal to. Pause the video, take a second to put the correct symbol between these two pairs of numbers. -2 is greater than -3, and 45 is less than 99. Review graphing. So we're looking at slope-intercept form. That is y equals mx plus b. Remember, the slope is the coefficient of x. It's the m. The b, the constant term, is the y-intercept. To graph these, we start at the y-intercept and then use the slope to graph the next couple points. And the more points you use, the straighter your line is going to be that you draw through them. With an inequality, it's not a whole lot different. We're going to start with the y-intercept and then use the slope to graph some more points. The difference is what we do after that. So in this example, we have y is greater than 2x minus 6. The slope is 2. The y-intercept is -6. So we start with the y-intercept, and then we're going to go up 2 over 1, because the slope as a fraction is 2 over 1. So up 2 over 1. And I'm going to plot a bunch of points so that I ensure that my line is as straight as it can be. And then I'm going to draw a dashed line through this because there is not an or equal to. And what this means is that points on this line are not solutions to the inequality. But there are going to be solutions on one side or the other of this line. And what we do is we pick a point. Test one point either above or below the line. And a good point to test is often 0, 0 because it's easy to plug in. 0 is greater than 2 times 0 minus 6. And we ask, is that a true statement? If the answer is yes, we shade that side of the line. So any point over here will make the inequality true. We could have picked a point on the other side, say 5, -1. So now -1 is greater than 2 times 5 minus 6. Is -1 greater than 4? No. So we shade the side that does not contain 5, -1. So this shaded region represents all of the points that will make this inequality true. On the next page, there are a bunch of examples, and what I would suggest is that you pause the video right now and attempt to graph all of these, and then come back and check to see if you're doing it right, or do them one at a time. But do them first and then watch the video. So for the first one, the slope is 2/3. The y-intercept is -4. So I go up 2 over 3. And there's not an or equal to, so we draw a dashed line, and then test a point, 0, 0. 0 less than 0 minus 4, 2/3 times 0. Is 0 less than -4? No. So we shade below this line. Another way to do this, if you have y by itself, this says that y is less than the line. Less than means go down, put your pencil on the line and move it down. That's the side you shade. The second one, the slope is 2 over 1. The y-intercept is 1. So up 2 over 1 from that y-intercept value. And we can extend the line going the other direction as well. Dashed again, because there's no or equal to. And here y is greater than, I'm going to shade above this line. Y values bigger are up. Right there. Three and 4. For 3, the slope is negative 1/2. Because this is negative 1 over 2 times x. The y-intercept is 5. So I'm going to go down 1 over 2 units. Or I can go back 2 and up 1, extending my line the other direction. And this boundary line, there's an or equal to, so I'm going to draw this boundary line in solid. The points on that line are solutions. And then y is less than this, or we could test a point, but less than y values are underneath this line, that shaded region. For number 4, you have to remember that y equals a number is a horizontal line. Y equals 4 is right here, and also right here, and right here. All of these points that I'm putting on have a y coordinate of 4. This gives us a horizontal solid line, and the y values that are less than that are all of these points underneath it. The 2 number 5s. The first one, remember this is really 1x plus 0. The slope is 1, the y-intercept is 0. People screw this one up quite a bit, but this is a diagonal line that goes through the origin and has a slope of positive 1. And this would be dashed because there's no or equal to. And y is greater than this, so we're shading above this curve. Plugging in 0, 0 to test a point would not work in that case because 0, 0 is on the line. X is greater than 5. This is going to have a vertical boundary line. X equals 5 is a vertical line. And x is greater than that to the right. Those are all the points with x values greater than 5. Now there's another way to graph lines when they're in what's called standard form, ax plus by equals c, or with an inequality in there. We're going to find the x and y intercepts. And it's sometimes referred to as the cover-up method. To find the x-intercept, if you think about that and think about a graph intersecting the x-axis, the y value there is always equal to 0. And for the y-intercept, the x value is always equal to 0. You can look at the graphs that we just made to see that. So what we're going to do to graph this is we're going to find the x-intercept. We're going to plug y equals 0 in there. To find the x-intercept, we're letting y be 0. So we essentially ignore that y term because 3 times 0 is 0. So we have negative 2x. And I'm going to let this just equal 12 to find the x-intercept. Now I can divide both sides by negative 2. The x-intercept is negative 6. To find the y-intercept, we're letting x be 0. So this first x term we ignore because negative 2 times 0 is 0. So we're looking at the little equation 3y equals 12. Divide by 3. Y equals 4. And we could then graph these points and draw a line through them. So here are some inequalities. We're going to graph them using this intercept method. So we're going to find the y-intercept. And to do that, again, we let x equal 0. 4y equals 8. The y-intercept is 2. And then we find the x-intercept too. To do that, we let y be 0. So cover up that y term. Negative x equals 8. Get x by itself. X equals negative 8. And we now have 2 points, and we can draw a line. And for this one, it's dashed because there's not an or equal to. And you should use a straight edge to do this. Or look at what the slope would be between these points and add another one, or multiple points. And then we plug in a point, say 0, 0. 0 plus 4 times 0, so 0 plus 0, is that bigger than 8? No, 0 is not bigger than 8. So I'm going to shade the other side that doesn't contain the point 0, 0. For the second one, to find the y-intercept, again, we're letting x be 0, so we're covering up the x term. We're left with y equals 3. There's no solving that we have to do there. And then to find the x-intercept, we let y be 0. So we're covering up the y term, and we're left with the little equation x equals 3. Again, no solving needed. And we can extend this pattern between the points, like so, if we need to get a straighter line, or if we have a nice straight edge, we can use that at this point. This one is solid because there's an or equal to. We want a good straight line. And then plugging in 0, 0, 0 plus 0, 0 plus 0 less than 3? My answer would be yes. We're shading everything underneath this boundary line. The second two, again, find the x and y intercepts. And it doesn't matter which order we do this in. If I make y equals 0, 2x equals 10. So the x-intercept is 5. Then we find the y-intercept by letting x equal 0. So cover up the x term. We're left with 5y equals 10. Divide by 5. The y-intercept is 2. And we can extend this pattern between these. Left 5 up 2. If we want to get a straighter line, or with a nice straight edge, we can make our dashed line going through these 2 points. Or 3 points as we have here. And then plug in the point 0, 0. 0 plus 0 is less than 10. Is that true? Yeah, it is. So we're shading everything on the side of 0, 0. Just to revisit this, x is greater than 4. Hopefully you have this drawn in as a vertical boundary line going through x equals 4. and everything greater than that would be to the right. The last piece of this section deals with solving inequalities. And to solve inequalities, what we do is essentially like an equation. There's only one instance where that idea has to change, and that's if we divide by a negative. And if that happens, you must switch the direction of the inequality. So, how do I get rid of plus 20? We subtract 20 from both sides. Negative 2x is less than 80. Divide by negative 2. X is greater than, pardon me, I divided by a negative. That's just something you have to pay attention to. X is greater than negative 40. And the whole reason behind that is if I take a true statement like 2 is less than 5, and I multiply both sides by negative 2. Now I have negative 4 and negative 10. Look at those numbers. What has to happen for this truly to be true? The inequality has to turn around. So with this next one, I have to add 7 to both sides. And there's two ways to go from here. I could distribute the negative 2, or what might be nicer is that's really multiplying, so I can divide by negative 2 right now. And since I divide by a negative, the inequality has to turn around. X plus 8 has to be less than or equal to negative 9. Then I subtract 8 from both sides. X is less than or equal to negative 17. If you would have distributed, we would have ended up with negative 2x minus 16 is bigger than or equal to 18. We add 16 to both sides. That would be 35. Take that back. That would be 34. Divide by negative 2. Dividing by a negative switches the inequality, and we end up with the exact same answer. It does not matter which way you do this, in the blue or in the red. Now, the very last problem here is asking us to get y by itself. Solve for y. Well, we need to get everything away from it, so we need to get rid of this plus 2x. We do that by subtracting it from both sides. And these aren't like terms, they don't combine together. So negative 2x plus 10. And then y still isn't by itself. I have to divide by 5. Well, I divided. But since I'm dividing by a positive number, the inequality stays the same. I'm left with negative 2/5 x plus 2. Now you might ask, why do I split it up like this? I'm putting it in a slope-intercept form, essentially, is what's happening here. The slope of this line would be negative 2/5, and the y-intercept is positive 2. So your assignment is the next worksheet that you have.
Anna Marie Wilford, if you're in
It's
the
due
building,
tomorrow.
please, Anna Marie.